Hi there, another video from me, Chemistry 1, this time covering multi-step reactions. Okay, first thing to do is watch the first video link that I sent you, only for the specified time period. Don't watch the whole thing, which is this one. So pause my video, watch that one and come back to me when you're done. That gives you a nice introduction to multi-step reactions. Okay, that video gave you a nice analogy using this image, basically stating that if cars need to travel from A to C, and the journey could be considered to consist of two steps, the journey from A to B, then the journey from B to C, it's actually the journey from A to B which is the really slow step of that journey. Cars have to slow down, pay a toll here, and then move on again. Once they get to B, they just zoom along to C. Now, therefore, A to B would be what we call the slow step, and is therefore also called the rate determining step. Because if you want to increase the rate at which cars can travel from A to C, there's no point in trying to increase the rate of travel between B and C. That would make virtually no difference. They already just zoom along. There's not much you can do to make that faster. The thing that's holding up this whole process is this part here. And if you want to speed up the journey time from A to C, you've got to slow down the amount of time they spend getting through this toll, or speed up, I should say, the rate at which they get through that toll. And this applies to any sort of two-step process. If you want to speed up a two-step process, you really need to speed up the slowest part of it. Another simple analogy shown here. The sand has to travel through this timer from the top to the bottom, but the thing that really slows it down and controls the rate at which it falls is the rate at which it moves through opening A. Openings B and C are not actually slowing it down at all, and therefore not influencing the rate. For example, if you made the opening to be even wider, it would make no difference to the rate. Same for C. If you wanted to make the sand travel more quickly from the top to the bottom, you'd have to increase the rate of travel through this opening by making it a bit wider. So this again is the slow step, often also called the rate determining step, because it is the rate at which it travels through here that determines the rate of the overall process. And if you want to increase the rate of the overall process, you have to increase the rate at which it can travel through that opening. Right, what's all this got to do with chemistry? You might be thinking, well, this point, pause my video again and watch the second video I sent you, just for the specified time period only. It gives you an introduction to how this relates to chemistry. I'll explain more after this. Okay, basic reason that this relates to chemistry is that for chemical reactions, we write balanced chemical equations, of course, but those chemical equations are often just a summary of the overall process, but they don't tell us the full story of what's going on in that reaction. That is because many chemical reactions are themselves two-step processes. For example, this reaction actually occurs in these two steps as shown here. Now, first step is the slow step, or the rate determining step. Two molecules of NO2 will collide with each other, but this happens very slowly and they will form NO3 and NO. As soon as the NO3 is formed, it immediately combines with CO and very quickly forms NO2 and CO2. But for the NO3 to be able to do this, it has to wait to be formed slowly in this step. It takes a long time to form it in this step. As soon as it is formed, it's then immediately used up in step 2. So step 1 is the slow step, therefore the rate determining step. And if you want to speed up the overall rate of this reaction, you've got to speed up step 1. There's no point in trying to speed up step 2. That occurs instantaneously anyway. Now, many chemical reactions are indeed two-step processes. Some are even 3- or 4-step processes, as we'll go on to see. Some aren't though. Some are just one-step processes. But in this topic, we're looking at those reactions which are multi-step processes. Right, having had a general introduction, about time we moved on to the actual skills you need to acquire to be able to answer exam questions on this topic. I'm going to take you through a series of problems. Need you all to get a pen and paper out at this point. I forgot to write a title, very sloppy of me. Tut. Multi-step reactions will do as a title. I would also like you to write out the steps for 1A. No need to write this top bit, but you can write out these two-step processes and these two lines, leaving space for an answer. Pause the video for a minute and get that done and then come back. Right, so this is the first skill. In this, you are given a two-step mechanism, and from that you have to write the overall equation and the rate equation. I will guide you through question A, and then you'll do question B for yourselves. Right, now in these two-step processes, there's always something that can be cancelled out somewhere, sometimes more than one thing. Something that is either is a product of step 1, in this case D, but is used up in step 2. As 1 mole of it is formed there, but 1 mole of it is used up there, overall it's not going to appear in the equation. Now, have a quick check there's nothing else you can cancel out, and there isn't. There's nothing else which is a product of one side and a reactant of the other side, no. And that means the overall equation, well, the overall reactants are 2 moles of A and 1 mole of B. So there's the overall reactants, and the products are just C plus E. So nice and easy, writing the overall equation. Rate equation is also nice and easy. For the rate equation, all you do is you put the reactants in the slow step into the rate equation. Can I just remind you, the first thing you do for any rate equation is write rate equals K. If you don't put that part down for starters, you've already lost the mark, but that's not finished yet. Okay, as I said, the reactants in the slow step A and B go into the rate equation, and they will both be first order in this case, so no need to put a number by them. The reason they are first order is there is 1 mole of each in the slow step. So it's the number of moles in the slow step that determines the order of reaction, not the number of moles in the overall equation. Note there's 2 moles of A in the overall equation, but there is only 1 mole of A in the slow step, therefore it is first order. Were there, for example, a 2 here next to B in the slow step, it would be second order there. Okay, let's go on to part B. You can do this one hopefully for yourselves. Copy out the 2 steps, write the overall equation and the rate equation. Pause my video, come back to me when you're done. Okay, there's the answer. You cross out G and you're left with the overall reactants being 2F plus I, overall products 2H plus J, 2 moles of F in the slow step. It's the only reactant in the slow step. In this type of reaction, when there's only one reactant, basically 2 molecules of F will collide with each other, forming a G and an H, and therefore that's your rate equation. Okay, that's that skill dealt with. Let's move on. Now, second skill, really this type of question is precisely the opposite way around. This time you're given the overall equation and the rate equation, and you need to propose a 2-step mechanism. Yet again, I will talk you through question A, then you'll do B for yourselves. But pause for a minute, copy out the overall equation and the rate equation. Right, first thing to always do here is the rate equation tells you the reactants in the slow step. It tells me there's 1 mole of A, 1 mole of B in the slow step. So I can put those down. Next thing I do is say, wait, let me look at the reactants in the overall equation. There's 2A and 1B. If I've only accounted for 1A and a B there must be another mole of A in the second step. So that's the next thing to put down. Now, from here, we know that there's always an intermediate involved in these reactions. You know, you had it in A there, D was the intermediate, and in B we had G as the intermediate. An intermediate is something that's formed in the first step and used up in the second step. After all, there must be something linking the two steps always of these reactions. You know, the second faster step can't take place until the first step has taken place. That's why it is a two-step process. The second step is dependent on the first being completed, and therefore there's always an intermediate formed in the first step but used up in the second. So we may as well better put an intermediate in here. Makes sense to just give it E. So I'll put an E there. Probably makes sense to say that, you know, if there are two products formed overall, let's form one of those in the first step as well. I'll put it as C. You could just as easily put D there. Now, E is our intermediate, which must be used up in the second step, and then obviously the other product of the second step must be substance D. So that's that one done. Right, there's question B. Copy it out and pause the video and have a go at proposing a two-step process for yourselves. Right, first thing you should have done, of course, is make F the reactant in the slow step, the only reactant. Therefore, the two Gs must be amongst the reactants in the second step. There will probably be something else there, so we're not drawing the arrow there. That's just the first step. Now, if you have one molecule only in a reaction, by the way, this is got to be a decomposition reaction where one molecule is broken down into two smaller molecules. We know there's always got to be an intermediate formed as well. We may as well use J as our intermediate. Make J the intermediate, and may as well make sense to form one of our two products in the first step as well. So we'll go like that. If you're still a bit confused by that, thinking how can one molecule turn into two? Well, it can happen in decomposition reactions. You've looked at several decomposition reactions before. Calcium carbonates. That's the thermal decomposition of calcium carbonate you've looked at before. One broken down into two, or this type of cracking reaction. Don't know if you still look at that, GCSE. One large alkane molecule broken down into two smaller molecules. This could be something along the lines of that. You do sometimes get decomposition. In fact, you saw one on the earlier video as well with CH3OH breaking down into CH3 plus and OH minus as well. So it can happen. Anyway, that's a slight aside. Let's just stick to the mechanism. And to finish off, H is our intermediate, so it must react with the 2G in this step to form our other product I, and that would do for that one. Okay, let's move on. Right, question 3. Not so much a new skill, something we've already covered. Again, you are given a two-step mechanism. Write out the overall equation and the rate equation. I just want to make sure you don't get confused by something that you will come across from time to time. So yeah, copy out the two steps, pause my video, have a quick go at writing out those two. Okay, there's the answers. In this case you can cancel out two things. D is our intermediate, formed in step 1, used up in step 2, but then also B is actually the other way around in a way. It's used up in step 1 but reformed in step 2, so you can also cancel that out. And your overall equation is therefore that. Then your rate equation is rate equals KAB. You can't leave B out of the rate equation just because you've cancelled it out of your process. It's still a reactant. 1 mole of B is a reactant in the slow step. Therefore, it must appear in the rate equation. But you can get confused. Well, how can it appear in the rate equation if it is not in the overall equation? Well, it certainly can. That is the correct answer, what I've put there. If you're still thinking, well, why? Well, let's stop and think for a minute, shall we? A substance which takes part in the reaction in step 1, but in the overall process is not used up. And in fact, its presence is required. The fact that it's in the rate equation means its concentration affects the rate of the reaction, and if we increase the concentration of B, the reaction will proceed more quickly. So it's a substance which can affect the rate of the reaction, but is not used up in the overall process. It is therefore a, pause if you need to think for a few seconds, is of course a catalyst. But note D isn't a catalyst as well. Intermediates that are formed in step 1 and used in step 2 are not catalysts, because you would not add substance D to the reaction. To get this reaction to take place, you would actually mix A and E, and you'd have to mix B as the catalyst as well. In fact, in the overall equation, you could, if you wish, write B over the arrow being a catalyst. You don't have to do that in exam questions, but that's just to emphasise it is a catalyst. And therefore, if you were carrying out this reaction in a test tube or a beaker, you'd actually add A, E and B together. You wouldn't add any D. If you were just analysing, unless you did detailed analysis of this reaction, you wouldn't even know that D was ever involved. And therefore, because you do add B, it is a catalyst. But just to summarise, a catalyst will be used up in step 1 and reformed in step 2. Not the other way around. It's not a catalyst if it's the intermediate, which means it is formed in step 1 but used in step 2. Okay, up to now we've only looked at A's, B's, C's, etc. Let's go on and look at some actual real chemistry, real reactions. Give you some problems to solve there. Let's start with this one. I think this was probably shown on video you've already watched, but let's check you can remember it. Copy out those 2 steps and then write the overall equation and the rate equation. Okay, up to now you've only been looking at A's, B's, C's, etc. About time we moved on to some real chemistry. Let's give you some problems to solve involving real 2-step processes. Let's start with this one. I think this was shown on a video you saw earlier, but good practice to do it again anyway. Copy out those 2 steps, and then from it can you write the overall equation and the rate equation. Okay, pause, come back when you're done. Okay, here's the answer. You can cancel out an NO2 and an NO3 in this case. Get that as your overall equation. Your rate equation, remember, because there's 2 moles of NO2 in the slow step, it will be second order. The fact that you've cancelled it out, one of them out to make the overall equation, doesn't mean you can remove them from the rate equation. There we are. Right, another one for you there. Part B, again, copy out the 2 steps and answer the questions. Come back to me when you're done. Okay, cancel out the NO3 again. You're left with an overall equation of that. 2 moles of NO2 in the slow steps. The rate equation is that, you might think, but no, it is not. I've done this deliberately to make a point. If you wrote that in an exam question, you'd have done all the deduction right and you still won't get the mark. You've got to write rate equals at the start. Now you get the mark. Okay, let's do it the other way around at this point. This time you're given the overall equation and the rate equation. Propose a 2-step mechanism. Pause again, copy the questions and try to work out an answer. Right, as explained before, first thing you do, 2 substances in the rate equation are the reactants in the slow step. Is there anything else that must be a reactant in the second step? 1 more molecule of ICl. So that's the first thing to do when answering this. Now, from these 2 reactants, we've got to form some sort of intermediate. We likely will form at least one of these products as well in the first step. So what could we get out of that? Now, as there are 2 moles of HCl formed in the overall reaction, it makes sense to think that probably one of those moles will be formed in the first step. So I'd put HCl as one product. What are we left over with from our reactants? 1 more H and an I. Trying to guide you through this step by step. That HI doesn't appear in the overall equation, so it must be the intermediate used up in the second step. And, as we need to get I2 and another HCl, we'll put those down as the products of the second step. That does balance with what's here, an I2 and an HCl, and there we are, with this being the slow step. When proposing these mechanisms, I should emphasise you should write either slow or RDS next to the relevant step. And again, right, here's the next little poser for you. Overall equation and rate equation, copy those out. Try to propose a two-step mechanism from that. Pause the video and come back when you're done. Yet again, that should be the first thing that you do. And again, if there's 2 moles of this being formed, it makes sense to think there will be 1 mole of it formed in the first step. That will just leave an F left over, which would have to be our intermediate reactant step 2. And that should be your overall mechanism. Right, getting a bit too easy, this stuff for you all, I reckon, by now. Let's ramp up the difficulty a bit, shall we? 3-step mechanism this time. Copy those steps out, write the overall equation and the rate equation, please. Okay, that's what you should have done. Notice there's 2 intermediates here, one sort of being linking step 1 and step 2, another one linking step 2 and step 3. You can cancel both of those out, and you should find that as your overall equation. Rate equation is always easy, just the reactants in the first step, both 1 mole of each, so both first order. Right, still way too easy for me. I can hear Sarah saying, I can hear Amy saying, give us something harder, will you? Well, if 3 steps isn't enough, how about a 4-step mechanism? Can you do this one? Again, copy that, pause the video and have a go. Right, there's your answer. Loads of things crossed out. Sort of a slightly unusual mechanism where step 1 doesn't really feed into step 2. It's almost as though steps 1 and 2 will occur simultaneously, but step 1 occurs much more slowly than this one. So this is still the rate determining step. But anyway, you can still, principles are mostly the same. You still cancel out loads of things, end up with that as your overall equation, that as your rate equation, and it's not necessarily harder than having 3 or 2 steps, to be honest, is it? It just takes slightly longer, but it's the same principles. Right, that's just about enough of me rabbiting on. Into your notes, can you copy the contents of slides 19 and 20 from the PowerPoint, annotate them a little if you want to expand on them. There's sort of little bits to complete on these just to emphasise things. Right, you can then move on and do section G on the question sheet as well. So that's up to the end of question 23. You should already have done section H. That will leave us only section I not done by this point. I've also sent you this additional question to practice. Good question this, which combines what we'd already learnt about interpreting data and rates with multi-step reactions as well. I've then also sent you a series of Quizlets to do. Don't try to do them all at once, actually. Do one of these today, the one the next day, one the next day after that. If you want rates and orders, just reinforce what you did last week. Couple on multi-step to reinforce what you've been doing today. Again, don't do them both on the same day. With these Quizlets, by the way. Right, when you click on the link I sent you, it actually takes you straight to the test part of the Quizlet, but you don't actually only have to do the test. On these, you could go through some of the other parts as well. If you go on the learn part of these, they also give you some further questions on that, which are quite good questions. And with each one you also get some flashcards at first. If you want to remind yourself of some of the principles behind some of this, you could read through those. You get various different aspects of these. It's certainly worth doing the learn as well as the test for each one. Although my link might take you straight to the test, you can just usually click on the back and get to the learn. If that comes up, just come off it. And you can go like that and get to this page. And do remember with some of these questions on the Quizlet, so you don't get confused, with some of these they actually sort of give you the answer and you have to guess which of these would be a relevant question to which that was the answer. Okay, I'll leave you to work through all that.